Greetings and welcome. It's been a bit hectic lately with Christmas and everything going on. We have our winter wonderland in place here a few days before Christmas. And I thought I'd work on a little bit of a technical challenge before I got to work on some of the other things that are developing on the layout. What you see in front of you is what's called a Y, W-Y-E, if you're not exposed to that before. And it poses a little bit of a electrical challenge, which we'll explain here in a second. This is a simple test track I've set up on this segment of the table, which isn't obviously developed yet with anything. And you can see it's simply a right-hand switch connected with the loop, effectively forming what they call the Y right there. And if you think about it, when you induce your DC at the end, in this particular case, if you would follow that outside track all the way around and continue to follow, it's going to eventually come back and then be the track closest to us. So our trusty Alaska made it to this point on our loop, or RY. Nothing special about the re-railers I put in here. I just use them to make my test loop. But if you look closely, why it stopped is right here. Between these two segments are plastic rail joiners, obviously meant to be non-conductive. So if we watch our Alaska come through, when it hits that point, it stops because now it doesn't have the correct power to power the locomotive. To visually try and communicate our technical challenge, if you're not familiar with this, here is a rough drawing of the layout we just saw. You've got the furthest rail and the nearest rail. I've made this diagram have the farthest rail be the negative power, so I made it red, right? Doesn't really matter. It's just for argument's sake, because if it was positive or negative, it wouldn't make a difference. Anyway, in this case, we're applying the negative power to the farthest rail. And if we follow that all the way around, where Alaska Loki was coming through, once it passes back to the Y and hits that rail right about here, whereas the outside rail was negative power, now the inside rail is negative, obviously creating a short and halting our locomotive. In the intro, you saw that Alaska locomotive halt right about here, and that's where I had the plastic joiners. That's where the short was created deliberately to show the problem, hence the Alaska locomotive stopped. Essentially, what we're going to have to build or make happen is isolate that loop. So with my high-speed graphics application, you see I've labeled different points in the track, A, B, C, and D. D will be our loop we're going to isolate. A remains a point of reference in our power source, and B and C are going to be important for the actual isolation. What you have to do is be able to flip the power as the locomotive enters the track at B, and once the train is fully onto that loop at D, you flip a switch, reversing the power so that when it returns over by C, the train continues to go. That's what we're going to try to do. Also important at this point is being able to put power on the loop itself. That's what will get switched. So the original run coming in at A will have a certain power scheme. Once we cross a point at B and C, and the train's fully in the loop, we flip the switch, and off you go. Now, this can be done with a double pole, double throw switch, or you can cheat. What I picked up is a Atlas AR1 controller. You can see it's a number 220 controller in its SKU system. And this particular one I bought for $5 on consignment at our local hobby shop. Normally these things run, I've seen about $30. And I think for our test, I thought this would be good because, again, this is the noob model railroader and trying to figure this out. Here on the back are the wiring schematics. This is exactly opposite of our layout here, but that's okay. And you can see the AR1 switch with the power supplies and various hookups or whatnot. You can find these schematics out there. Just look up Atlas reverse loop or Y wiring or something like that, and you get this exact diagram out there. Hopefully this thing is in operating condition, and we'll give it a check, but we'll figure this out together. So what I've accomplished now is installing these plastic isolators on both segments of the rails. And I found these orange ones in my stash, which makes them more visible. You can see. A little worried about this one because it's a little bit rough, but you can see now when we send our Loki through, once he passes, that he's out of power. So what I have here is our standard transformer, taking out the variable DC power, saving some wire here for later, so I'll apologize for the mess, and I've brought it over to the common side on the 220 controller. And just like extending your transformer connection to this or to the track, same thing here. But then it gets a little bit different. What you have is there is a common rail in here. You can see a X, Y, and C. Not very clear. So you have a common rail power, and I've extended that negative power all the way back to that segment. Then, to preserve the positive side, there's a bus underneath this switch, and again, you can refer to the wiring diagram to see how that works. I've taken the opposite power and going back here. So much like coming straight off the transformer, however, it's going to go through this switch. Now, back here on the loop in the D segment, you can see now it's positive and negative power come back to the X and Y side of this 220. There it is, okay? Okay, let's watch what happens. So I'm only dealing with the cab A switch and have the direction set as such. And the X and Y side is set here. So now we apply power. Here comes our Alaska. It's going to approach the isolators and stop. So right now, I have my loop selector in this direction or forward, and the main section, the A section over there, as the same. Okay, I know it's hard to visualize this if you're not actually here, but let's apply power to our Loki and see what happens. It stops until I flip the switch on that A segment polarity. And let's watch. There it goes. Okay, so right now I have my direction or polarity on the A segment set as forward, and on the loop set as backward. So let's watch what happens. See, the locomotive stopped again until I come back and flip this polarity the correct way. Let's just watch it go around. It's a little laggy because of my test segment. I'm gonna come around and watch this. We stop once again, right? So now, because we're back in the A segment, I have to flip that direction for it to continue and hopefully stop in time before I run it off the end of the table. There, get our Loki into the loop through a little bit of a soft section. I'm going to flip the switch on that main line. It's going to enter the Y and keep on going. And that's what we want. So I'll probably rearrange this Y to where I can loop into some of my existing dual track back there, because it's going to be quite a while before I get to this section of layout on this table. That way I can run some trains, because while building scenery and terrain and whatnot is fun, it's also kind of fun to see some trains roll. In addition, allow me to continue to test and see how this segment of the track ties in and integrates with the rest of the layout.